Welcome to EDU World Space.
We know that when we're on the surface of the Earth, a distance re, the radius of the Earth from the center, that the acceleration due to gravity is 9.8 meters per second squared. So this problem asks us to find a distance d from the surface of the Earth so that the acceleration will be 0.98 meters per second squared, so just a tenth of what it was. We can do this completely analytically and mathematically if we want, but it's probably a little bit easier just to look at our equation for the force due to gravity, and we can kind of reason our way through this. So if the acceleration is decreasing by a factor of 10 between these two situations, that means that the force must have also decreased by a factor of 10. And so we know that the gravitational constant isn't going to be changing here, and the masses aren't going to be changing either. So the only way this can happen is for the denominator, the distance squared, to decrease by a factor of 10 between these two cases. So that means that our new distance separating the center of the Earth and the person, or whatever object is in this gravitational field, needs to be, so that squared needs to be 10 times greater than what our original distance, the radius of the Earth, was. So we can solve for that pretty easily and find that this distance needs to be the square root of 10 times the radius of the Earth. But that's not quite our answer yet, because they don't ask us for the distance from the center of the Earth to the object. They ask us just for the distance from the surface of the Earth. So that means that we kind of need to subtract off this distance here, the radius of the Earth. So d then, the distance they're asking for, is square root of 10 times the radius of the Earth, and then minus the radius of the Earth. So we're just taking off this little part right here. So we can simplify that a little bit if we want. So that looks like it will be square root of 10 minus 1 times the radius of the Earth. And when we evaluate that, we should get 1.38 times 10 to the 7th meters. And there we go.